My channel. Today I'm going to discuss about digital number systems. So basically, before going to the digital logic number systems, so here we should know about what is data. Okay, so what data means is nothing but a set of values or information to represent any kind of data. Okay, so this information is processed by the computer. The computers don't know about the human language, but how human is able to talk to the computer? That is the question. So the computers need to process the data and also store the data and also represent the data, okay, and also transmit data. So if you want to do all this process, storing and representing and transmitting, so we require some technique. The technique name is called as data representation. So the human must know about the data representation to convey the information to the computer. So computer basically don't know about that human language. Computers only knows about the zeros and ones. But how we are able to communicate your data to the computer? So with the help of some technique. The technique name is called as data representations. So computer can take the data from the user. So computer can transmit the data as electrical signals, and also computers can store the data in the magnetic form, like a magnetic tape or optical form. So in the media, okay. So when you come to the data representation, so we have there are different ways to represent data. So one is we can use the binary codes, and the second one is number systems. Bus systems. So in the binary codes, we have seen the lot of number system binary codes are there to represent different kinds of data, like a weighted binary code, non-weighted binary code, and next one is alphanumeric code, and next one is BCD codes, and next one is error detecting and also error correcting. These are all the codes to represent data in the computers. So today I'm going to discuss about number systems. So how to represent numbers in computers? What are the different ways are there uh, to represent numbers in computers? So we have basically four types are there to represent data in the computers. Our data may be numbers. So the four types are, the first one is binary number systems, and the second one is octal number system, and third one is decimal number systems, and fourth one is hexadecimal number systems. So each one has some unique advantages when representing numbers in the computers, in the modern computers. Let's see that the first one is binary number systems. So binary means so here that a base or radix is equal to 2. So what is base or radix? My question is. Base or radix means a number of digits used in the number systems. So when you want to represent any number in the binary only, we have two digits only, like zeros and ones. We don't use other numbers apart from zeros and ones. So let's see that. So here we can consider the binary number systems will be used in when viewing the programs in the computers. So when you want to be write any programs like using C language or another language, the programs must be stored in the form of in the binary patterns only or in the binary form only. Okay, let's see that how to find out the value of digit in the binary. So value of digit in the binary. So we have always knows about the position of that digit, and second one is so power of base. Okay, power of base. So position. So each digit in the number system has some position. So and also it has power of base. The power of base always the binary have two power, two power position. Okay. So this is the way you can calculate the what is the value of digit. Let I'm taking that simple example to know what is the value of digit. So let I'm giving the example here. The first one is a binary and number, and the second is the power of base, and third one is a magnitude or value of digit. So value of digit. So because of digits are placing in the binary different positions, we should know what is exact value, what is the exact value of that position. So we should know by using some formula or from fundamentals. So see, let I'm having type 101 point, suppose 01. So this is the binary value. The binary value. So it has only the combination of zeros and ones only. Apart from the zeros and ones, there is no other value. So that is the advantage of binary numbers only. Let's see here. I consider the power of base is always two powers. In always two powers. So the first position is means zero position, 2 power 0. One position 2 power 1. Second position 2 power 2. The dot, so this position is nothing but 2 power minus 1. This is position is nothing but 2 power minus 2. This is the power of base of each position. Then you get the what is the value of this digit. So you can multiply the binary value or binary number into the power of base, which is called as 2 power 2 is 4. That means 1 into 4 is 4 only. Then 0 into 2 power 1 is 0. Then what is 1 into 2 power 0? 2 power 0 is nothing but 2, 1. Then it's called as 1. So 401 point. So 401. So this each digit value. So 2 power minus 1. This means anything is multiple 0. So 2 power 2 is nothing but 1 divided by 2 power 2 means 1 by 4, which is equal to 0.25. 0.25. So if you want to know the decimal value, so till now we have seen that what is the value of this digit. So this is 1 is placed somewhere in the number of binary systems. So what is the exact value of this digit? We should know by this process and get the values 4 only. So if you want to get the decimal value, you can accumulate all these numbers. So 4 plus 0 plus 1 point 0 plus 0.25. Then the final value is 5.25 is the decimal value. This is the way you can find out the value of binary into the decimal. So the second number system is octal number systems. So when you come to the octal number systems, so the base or radix is h. That means it has total 8 number of digits present in the number systems. Okay, the 8 digits are 0 to 7, which means 0, 1, 2, 3, 4, 5, 6, 7. Apart from the 7, okay, there is no other numbers are present in this octal number systems. And the one more important thing is, so here the power of base is always 8 power. Power of base is always power of 8 power. So 8 power positions, we have get the positions. Okay. Then the advantage of octal is very easy to represent the binary values in the octal. So when you see each octal digit, whatever the octal digit, each octal digit is equivalent to the 3 digits in the binary. That's why when you want to represent numbers in the binary, it is very difficult when you take the large width. So in order to reduce that width of the digits in the binary, we can go for the octal number systems. Let's see that how to get that one octal digit in the 3 bits format. Let's see. So 2 power 3 equal to 8. Octal is 8. The 8 you can write as 2 power 3. That's why 3 bits or 3 digits equivalent to 1 digit in octal. So let's see that how to find out the value in octal. Same way you can do. The first one is octal number. The second one is power of base, and the third is magnitude of each value or value of each digit. Okay, let's see that here you can note down that some you can take one number which is something 1 4 3 point something 1 2 like this is called octal because we have seen that the 1 is in the octal, 4 is in the octal, 3 is octal. Okay, the power of base means so 8, always you should remember that base is 8. So the 3 is at the position is 0 and 4 is at position 1 and 2 1 is at the 8 power 2. So this is nothing but 8 power minus 1, this is 8 power minus 2, then you can get the value. So 1 into 8 powers means is 64 obviously. So 4 into 8, this means 32. 4 8s are 32. So 3 into 8 power 0. 8 power 0 is 1. 3 ones are 3. Then dot. Okay. So 1 into 8 power minus 1. So this means 1 into 8 power minus 1, which is equal to 1 into 1 divided by 8. So it's not 1 divided by 8 only. Okay. This means 10.125 like this. So then 1 divided by 2 into again 2 into 1 divided by 8 square. You'll get some other value. So by using calculator and you will get the value. Okay. So the value would be something some other value. So 2 into 8 per 64, that means 1 divided by 32 like this. Some other value is there. You can accumulate and you will get the exact value in the decimal. So 64 plus 32, 96, 96 plus 3, 99 point something some other value is there, so you can accumulate 0 1.25 and here the value is there, you can use the calculator and get the value 99 around 99 point something. Okay, this is the uh, decimal value, so we'll get it by using calculator. And next number system is decimal. So this is our familiar number systems because of in our daily life we use only the decimal number systems. You know, right? So we need to know the time in your watches, or you need to count the numbers when you can see the traffic controls, when you can see the any applications only based on the decimal number systems. So that's why. So this is our daily life number systems. Base or radix is here 10, so which covers total 0 to 9. So this will be used in the mathematical computations. Okay, and also it will be used for counting the numbers like that, and all the real-time applications which based on the decimal number systems only. Okay, so once we know the decimal number systems, again we can do that same process. The base number means I'm taking that. So any number which is you know, right. I have taken that decimal number. Decimal number is something same 143 point something 10 like this, and power of base. The power of base is nothing but 10 power, as you know, because radix is 10. So this 3 is at some position 10 power 0, the 4 at some position 10 power 1, 10 power 2, and 10 power minus 1, 10 power minus 2. Okay. So when you can see that, so what is the magnitude and magnitude or value of each digit we can calculate. So 10 power is 100, this is the 100th value, this is the 4 times 40, this is 3 dot 1 divided by 10, this means 0.1. So this is 0 only, right? Then we want to get that decimal value 100 plus 40 plus 3, the 143 point again same 10, right? Same number because of we are doing that decimal number systems. And let's come to that last one is which is hexadecimal number systems. Decimal number systems. So here the base or a radix is 16. So means it has a total 16 digits. 16 digits. Out of 16 digits, first 10 digits are 0 to 9. Next 10 digits are A to F. So why A to F is coming into the picture? Maybe you have doubt. So see, when you see that the numbers are from 0 to 15, obviously there are till 16 numbers. So when you can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there is no problem. When you can write the 10, so 10 is a combination of 1 and 0. It is maybe combination of previous digits 1 and 0. So some next number is 1, 1, combination of 1, 1, 1, 2, 1, 3, that means 13, 14. So 15. So means the next 10 to 15 also is combination of zeros and ones or some other numbers in the decimal only. Then how to differentiate a 10 value, okay, or 11 value? So in order to overcome this problem, we use that encoding technique to represent the 10 value as A, 11 value as B, and 12 value as C, 13 is D, 14 is E, 15 is F. That's why in hexadecimal systems, so we have seen that 0 to 9 numbers and A to F numbers. Okay, and the power of base is always 16 power positions. Okay, please remember that power positions. And use case is hexadecimal system will be used for mostly when to represent memory locations in the computers. Okay, memory locations in the computers. And the four digits in binary, that means one digit in hexadecimal equivalent to four digits in binary. That means, so hexa means 16. 16 you can be write as a 2 power 4. That's why four digits in binary is equivalent to four digits in binary is equivalent to one digit in hexa. So this is the important thing is you should remember that. That's why when you want to represent, suppose I have data is 8 bits, something 1011, something 1001. So instead of writing 8 bits, we can write as saying two digits only. 101 is the 13. So 13 you can be write as right, 13 as a D. You can write as a D. This is the D. What about this one 9, right? So D9 you can write as D9. It's very easy to write in hexa format. So that's why we prefer the hexa format to get the locations in the memory. So once you understand the hexadecimal number systems, so the same way you can follow the magnitude of digit. That means hexadecimal number. So next one is power of base, and next one is magnitude or value of each digit. Each digit. Let's see that. Take any number like right. This is a combination of right something is BC ABC dot something 10 like this. So you can multiply power of base 16 power 2, 16 power 1, 16 power 0, and 16 power minus 1, 16 power minus 2. You can multiply A. What is 10? A into 10. A is equal to 10. 10 into 56. 2560 like this. So B is 16, right? So B is nothing but 11. 11 16s are 176 like this. C is nothing but 12. 12 into 1, 12 only like this. You can get the values by using calculator. You'll get the values. So if you want to get the decimal value, you can accumulate all these values and you will get the final decimal value. So in this video, these number systems are very, very important when you want to represent numbers in the computers. So thank you everyone. We will see the next topics in the next class. Please subscribe and watch my video.